Hello, my dear friends. Welcome back to all of you on your channel that is on JEE Physics Maniac. It's been a long pause. Yeah, it's quite been on and off time, but I'm trying to cope up with the health situation and trying to be regular with you. I really missed you in the span. So, all my dear champs, let's proceed without wasting much time. So, here the question says that the ends of the uniform bar of mass m slides freely in the horizontal and vertical guides. Examine the stability conditions for the positions of equilibrium. The spring of stiffness K is undeformed at x equal to 0. No problem. So at this particular position, the spring is said to be undeformed. And we have to check the condition of equilibrium. Now to check the condition of equilibrium, we have to follow three steps. One, we have to find out the value of u as a function of theta, and then we have to figure out the equilibrium position, that is by making du d theta is equal to 0, and third we have to check for d2u d theta 2. So it's a three-step process. So at any arbitrary position x, I am calculating the potential energy. For the spring it will become half kx square. All right, it's a very simple thing. It will become half kx square. And for gravity it will become mg into b by 2 cos theta. It is also very simple. You can understand from here that this total length is b, so half length will definitely from here to here it will be b by 2. So from here to here also b by 2. Then if I take this as the reference level, so this distance it automatically becomes b by 2 cos of theta. So that's why it become mg into b by 2 cos theta. So for the whole system the term comes to be half kb square sine square theta plus mgb by 2 cos theta. In the meantime, I have calculated the value of x in terms of b, which is very easy to calculate because if this is perpendicular and this is hypotenuse, so then definitely x is coming to be b sine theta anyway. So going ahead, now we will just differentiate the total potential energy. We will get two conditions. One is sine theta is equal to 0, another is cos theta is equal to mg by 2 kb. Do check your own calculation because as you know I am a self-proclaimed champion on calculation mistake. So do not trust me completely. And if you go by the same line at Richard Feynman, he clearly said that doubting is an integral part of education, especially learning physics. Anyway, so I will proceed with the case 1. I am taking sine theta is equal to 0 and I will try to get what we can get from here. So here I have done the double differentiation also, and little bit rearrangement gives you d2u d theta 2 is equal to kb square into 2 cos square theta minus 1 minus of mgb by 2 into cos theta. So this is the total term that I am getting after double differentiation. Now from this particular thing we will try to get the idea of the equilibrium. So for the first possibility we have already discussed sine theta is equal to 0. That means theta is equal to 0. So if theta is equal to 0 and if I substitute this possibility here in this particular equation, we get d2u d theta 2 is equal to kb square into 1 minus mg by 2 kb. Now see, these kind of cases are very beautiful because you cannot decide any one particular outcome of it, because here if you see that I will draw case 1 or case A. In case A, 1 minus mg by 2 kb is greater than 1. So in that case, I can clearly write that 2 kb will be greater than mg, I'm sorry, I think I am writing wrong. So here in this case, mg by 2 kb, this factor will come on the right hand side. So as rightly I have said that this factor 1 will be greater than 1 plus mg by 2 kb. So my whole point is very simple. If this entire idea has to be positive, why? I do not know why unnecessarily I am doing all this calculation, because this thing can be done pretty easily. If this particular quantity has to be positive, then I can directly write that 1 has to be greater than mg by 2 kb, right? All right, it's a pretty simple thing. So from there we can write 2 kb or k is coming to be greater than mg by 2b. So this is one condition. So in this condition, what ultimately I am getting, my point is that in this condition, d2u d theta 2 is coming to be greater than 0. If that is the case, then we know u will be achieving minima, and under that circumstances it will be stable equilibrium. Okay, and if I go by the other case, in that other case, if this entire factor has to be negative, then k has to be less than mg by 2b, and in that case d2u d theta 2 will be less than 0. In that case u will achieve maxima. So when u is achieving maxima, we are going towards the unstable equilibrium position. So that is one of the cases that I have discussed. I am leaving this particular case for your practice, as many of you have suggested, sir, please leave something for practice of us. So I am leaving the second case for your practice. Do let me know your answer in the comment box, and till then, enjoy, study hard, work very hard. Very soon I will come up with a video of suggesting practical books to learn physics at the high school and a little bit higher level. So stay tuned till then. Bye bye. Thank you.